In this lecture, we will implement precise hand attachment with animation override, all customizable per grab component, with preserved ability to react to input. Let's get started. First of all, let's find our VR pawn. Here it is. Now let's find one of the hands, and here we have the animation blueprint, which handles the animation. Here's the whole animation graph that we have, where we blend different animations. If you remember from previous lectures, all of them represent different finger twist, and by blending between them, we simulate this kind of finger movements. Like, for example, these ones when you have nothing in your hands. But in order to override this, we'll have to create the animation layer interface. Let's call it just VR hand. Let's open it. And here let's create just one anim layer, call it idle. And we will have to add inputs over there. And for inputs, we're gonna add all these float values based on which we perform the blending for the input. This will help us, and we will, by doing this, allow all the anim layers overrides to handle input in the way they want to. And we're gonna be using this in this lecture. So let's create one blending input variable for each blending variable from the original animation blueprint. Of course, for any kind of grip, you can just use a single animation, and you will be able to do this with our approach, but this approach is just more powerful. It allows you to use, for example, the combination of animations and use the values from input if you wish to. So roughly speaking, it allows you to create logic. Now we're gonna have to open class settings, find interfaces, and add our newly created interface. Let's compile. Now we can see our idle animation layer over here. We're gonna later put the logic inside of it, but let's first drag it to our graph. As you can see, right now we can see no inputs. That's because they are not set to be inputs over here. So let's use direct binding to the variables. This will automatically bind the inputs of this anim layer to the existing variables without the need by us to do that manually. Here it probably should be the current one. So we use the current one. We do have two current variables because we have original input for those, but we are smoothly interpolating over time. And for that purpose, we use the current. So let's put the idle animation as the basic pose, and let's connect the output. Now let's just select everything here except our newly created anim layer, and we're gonna just put it inside our idle anim layer. Here it is. Let's find our input node. Nope, not this one. Yeah, here it is. As you can see here, we have all our inputs. Let's connect the input pose so we don't have to use it over here, as we have already passed it. And now we will disconnect our variables because we're gonna use them directly from inputs over here. Later, as we're gonna use different animation blueprints that will override this layer, we also are gonna be using just the inputs because those animation blueprints just won't have these variables. So they have to be used as inputs. And it looks like I have forgotten to connect the output when I was recording. Just please do it right now. The graph should be running like this. Now we have to create another animation blueprint exactly for our pistol grip. Here we have our skeleton. Let's just call it something like ABP VR hand pistol. Let's open it. And here again, we have to add our interface in class settings. So it's VR hand. Compile, and we see our idle layer that is, as you can see here, is empty. But we still have our inputs and can still handle them correctly if we need to. So let's go here, and if you just have the correct animation, you can just use it. But I do not have any animation. So let's construct one from these that we have here. And we will also preserve the ability to move the point finger in order to look like we are shooting. Probably we're gonna need these two. Let's just copy them to the newly created animation blueprint. So as you can see, I'm not using the original pose input, and we don't have to do that, it's optional. Here we will purely construct the new animation from these two animations using Blend. And as you can see, I'm using the input of the point finger to simulate the shooting, the triggering. And I'm using the trick here with the clamp because we need the point finger to be at a specific location on the gun. Alright, I think we've done with VRPawn for now. And because we want this animation logic to be overridden per grab, we have to modify our grab component. First, we're gonna need a few more functions. The first one gonna be try find hand mesh on the controller and will help us to exactly find the skeletal mesh we want to attach to the grabbable object to the specific socket. And the other one will just directly capture this skeletal mesh. And probably we're gonna need one more for actually releasing the hand mesh when we drop the object. You know, maybe let's add the try prefix here. Let's just leave a room for some potential failure of the attachment. I don't know if anything happens. Now it's time for variables. First, we're gonna need the name of the socket we want the hand to be attached to. The next variable will be about the animation blueprint override. So the animation layer that we have created idle in this case gonna be used from this animation blueprint. And here it's called just animation instance class reference. Because after releasing the hand, we will have to attach it back to the controller exactly relatively as it was before we snapped it to our socket, we're gonna cache its transfer as it was before we captured the hand. Alright, let's start the implementation. We're gonna start with try capture hand mesh function. Here, first of all, we're gonna have to get our hand skeletal mesh, so we have to get our motion controller reference. And here will go the call. As you can see, we don't have it suggested yet because we don't have the inputs created so far. So let's add the required inputs, which is in our case gonna be the motion controller. And inside this function, at this moment, we're gonna find and return the skeletal mesh. Which also means we're gonna have to add the output, which gonna be just the skeletal mesh component reference. Alright, now first of all, let's check if it's valid, because anything can happen. Maybe we don't have a skeletal mesh hand, maybe we failed to find it for some reason. And probably we're gonna have to create one more variable exactly for our mesh. So we're gonna use that reference when we will be detaching the hand on dropping the object. And as you may have guessed, we're gonna set it over here. And it doesn't want to connect, maybe because the type of this variable still the motion controller. It should be the skeletal mesh component reference. Let's try one more time. Yeah, everything connects. Now, because we're gonna have to do two different things, let's create a sequence. The first part is to override the animation. For that, first we're gonna have to check whether this class is even valid. And if it's true, so the class is valid. We're gonna get our mesh, you see, so we have stored it to the variable, now we can use it everywhere while we are grabbed. And we're gonna link the animation layers here by just passing this class. So from now on, that idle that we have overridden in the newly created animation blueprint, the logic from that idle gonna be used, not the original one. Let's parameterize this even more and create another Boolean variable, capture hand. Using that, we will determine whether we even want to get the skeletal mesh and attach it somewhere, or it's not necessary. So first part, where we override the animation, and now Let's check whether we even want to capture the hand. And if true, they're going to be the second part, where we will attach the skeletal mesh from the controller of the player to the socket on our grabbed object. So speaking in terms of the gun, to the specific place on a gun that we will specify directly later. I will show you how. So remember, I was telling you that the relative location of the hand to the controller can be non-zero, so we have to cache it because we will have to restore it after we are dropping the object. We have to return the hand back to the controller as it was before with no differences. And now the attachment. Let's use the attach component to component function. We connect it right here. So now we have to find the parent, and we assume that it's just gonna be our attached parent. So it's gonna be the object, the component that this grab component is attached to. Here we're gonna do just snap and keep world for the scale. Okay, but now, because we want this attachment to happen to a specific socket, we're gonna have to pass the socket name. And in our case, we have to remember that we have two hands, which is obvious, of course. And for each grab component, the left and right hand might have a little bit different locations. So what I want to just do here, it's pretty simple. We're gonna create two sockets with, for example, some basic name and with the same name, but with underscore inverse. So here I will use the default variable, or I will construct the new name using the underscore inverse. And we have to convert this to a string first and then to name. Yeah. And we're gonna do the selection depending on the hand we are trying to grab this object with. And we can do this using the already existing function, which is called getHeldByHand. Let's call this function over here. And as you can see over here, we are interested just in two enum values, left or right. So here we have to use equal. It's important equal enum, not just equal. And as you can see, we have here a huge amount of motion sources, but we're gonna just use the right. And if it's equal to the right, we will return true. Otherwise, we're gonna return false. Okay, so we have created our try capture hand function. Now let's call it. And we're gonna do this inside the try grab function. Over here, when we are confident that the grab has succeeded and we've set the motion controller reference, we're gonna try to call our function and capture the skeletal mesh hand. Now let's implement the release hand function. Again, so we've done two things, attachment and animation, and we'll have to revert both of those things at the moment we drop the object. Let's again start with the animation. Again, here we will check whether this class is valid. So we check whether it's true, and here we still have the reference for our mesh. We're gonna have to unlink the animation class layer. After this, that idle logic that we have created will be again used from the base animation blueprint of the hand. All right, now the second part is our hand attachment. Again, we will check whether we were capturing the hand in the first place using the same Boolean variable. And after that, here we're gonna have to attach the skeletal mesh, which is currently attached to our parent socket, back to its motion controller. And we're gonna have to preserve its relative transform that we have cached at the moment we actually first captured the hand. So again, let's use attach component to component, and we still have our motion controller reference. Let's pass it here as the target parent. Talking about the attachment rules, we will just use keep world everywhere, because after that, we're gonna restore the relative transform as it was before the initial attachment, using the variable we have created before. Let's grab our cached relative transform and just pass it over here. Alright, cool. So looks like we have our try release function that will return the skeletal mesh hand back to the motion controller. Now we're also going to have to call it somewhere. And we're going to do this inside the try release function. Let's grab it. And again, we're going to have to call it somewhere we are sure that we have successfully released the object. Yeah, here it is. We still have one helper function left. It's about finding the mesh on the controller, so let's implement it. First, we're going to have to get all child components of the motion controller. Then we will iterate over them. And here we're going to cast this to the skeletal mesh component. And in case it's valid, we will just return it. So in case we will iterate over all the components and find 0 skeletal mesh components, we'll just return the empty mesh. So it's just going to be invalid after calling this function, and we won't do anything. We still have one thing left to do, and it's input. Because we are using different input actions on our pawn and on our pistol to handle technically one thing, is the point finger. We will have to use the input actions from the pistol in our pawn. As you can see right here inside our pistol, where we are pushing its own input mapping context, let's take a look. Yeah, so here this action is, and here we are handling this finger with a different input action. So we want our variables for the finger still to be passed to the animation blueprint. That's why let's just handle in the pawn again directly those that are used by the pistol. We can just do it right here for the left and for the right. And in our case, we'll be able to just copy the code from the existing one for the point finger. Yeah, let's just copy all of this and paste it over here. Now we just have to correctly connect everything and it should work. Here we're gonna have a Boolean input converted to float, but if you remember, we were clumping it in our pistol animation blueprint. And now we're gonna have to do the same for the other hand. Let's again just copy this, paste it here, and connect in the same way. Cool. So this code will help us to still react to the shooting input. And what we have left is actually to add our sockets. So let's find the pistol skeletal mesh. And now we're gonna have to create the socket where our hand gonna be attached. As you can see, we already have one socket here called grip point. So let's try to add a preview mesh. Let's type XR, right? Here we have our hand. You see that's how it might be rotated at the moment if we will do the attachment. And as you can see, the scale here is 0.5, so the hand is relatively small. So just for make our life a little easier, let's scale it here because we still won't be using the scale from the socket, but it's gonna allow us to correctly adjust it. In real projects, it's a rare thing to use scaling for such things. Usually everything should fit from the moment of creation, but this is just a template project, so we have to take its specifics into account. So we have to now modify the socket location rotation for the hand to ideally fit to our pistol. Again, so we are constructing the animation in our animation blueprint. If you have some specific weapon and you have a specific animation, you can hit preview animation in the top left and just directly see how your hand will behave. It's just not exactly the case for us, so I'm not doing it. Now let's duplicate our socket remember? And we're gonna add underscore inverse. And here we will attach the left hand. So here it is. Let's move it and rotate it to the correct location. Let's try maybe just to inverse this and rotate. Well, it seems to fit well. Technically, we could have just used some axis inversion, but I think this way is the easiest for us right now. Now, let's open our pistol and find the grab component, and we will specify the socket name. We can just copy it from here, right at the grab component. And for the anim layer, it should be our new pistol animation blueprint. And capture hand should be set to true. At this moment, we have created two sockets and specified the name of one of those inside the grab component. And if you remember, here we were selecting the socket or its inverse version based on the hand. So in our case, the inverse version will represent the left hand. There is one improvement we're gonna have to make, and it's over here. We're gonna have to handle the case when we are grabbing the same grab component with the other hand. And in this case, we're gonna have to release the old hand skeletal mesh because it won't work like this out of the box for this example. So here we will call try release. By the way, as it returns the Boolean variable, so it can fail to release, we will also have to handle this case. So in case it's true, we will just continue. And in case it's false, we will just return. And here, for the case we are not held, we will skip this release function call and proceed directly to the grabbing logic. All right, I think we've done. Now you can put your headset and let's see how it works. So let's move closer and try to grab our gun. As you can see, the hand gets snapped directly to the socket, and when I shoot, my finger moves in this clamped range, so the input is still handled. And let's try the left hand. The left hand is correctly attached to its socket. Again, let's try the input. It works. Now let's try to drop. Yeah, everything seems to work. So we have successfully implemented the animation override and hand attachment.